Hello students, and welcome to this calculus lesson. During this lesson, we're going to be learning about finding net and total distance. You're going to find some similarities, and you're going to understand how to find total distance and net distance using velocity and acceleration. So let's get started. So right here in this video, we're going to be kind of doing a review of what we learned in our last lesson about acceleration and velocity. So right here in this graph, we're given v of t. So let's go ahead and label this as v of t. And we know it's getting measured in meters per second. And so this is the distance, or sorry, this is the velocity of some sort of particle moving along the x-axis. So our first question is, what values of t does the particle have no acceleration at all on 0 to 10? So it's not saying it doesn't have any acceleration, like the acceleration is equal to 0. It's asking for no acceleration when is a of t undefined. So when we're wanting to say this answer, looking at our graph, there are several points where the graph is undefined, and you want to think back, okay, when we're looking at derivatives, where are derivatives undefined? Well, that's going to be where we have like corners or cusps. So we're going to say here that a of t is undefined at t equals 1, 3, 6, and 8. The reason for this is because the graph of v of t has corners. So remember to make those connections between the graphs of f prime and f double prime, because that's going to give us velocity and acceleration. So looking here at the second question, we want to express that acceleration as a piecewise defined function. All right, so we're going to have a very large piecewise defined function, not a problem. And as I'm looking here at our graph, you know, we just want to describe all the different segments of this graph. So I've got a segment here. And what is the rise over the run? Well, that's 3 up and 1 over. So then that's going to be equal to 3. And what is the range that that's going through? Well, that's from 0 less than t less than 1. All right, let's keep that going. On the next part, we're going down 6 and over 2. So then that's going to be -3. And that's on the interval from 1 to 3. Here in this interval, we can see that the entire thing is going to be 0. So we want to say, okay, the acceleration is going to be 0 because we're looking at the slope there. And that's going to be from 3 to 6. In this next segment, it looks like it's over 2, but it goes up 6. So that's going to be +3 for a slope on that line. So that's going to be from 6 to 8. And finally, on this last segment, we go down 3 and over 2. So then that's going to be -3/2. And that segment goes from 8 to 10. And that's all we have to do here. We have the interval from 0 to 10 written out for the acceleration, which is the derivative of the velocity function. And we have that piecewise function defined for all those segments. So now we want to say, okay, for what values of t is the particle moving to the left or to the right? We always want to justify our answer. Well, we know we're moving to the right when velocity is greater than 0. All right, so looking at our graph, when is it greater than 0? So we have positive values in all of this space. In all of this space, we have positive values. So then that's going from 0 to 2 and 7 to 10. I'm going to write here on 0 to 2 and 7 to 10. We know that it's moving to the right because velocity is greater than 0. And on the flip side, we know that we're moving left when velocity is less than 0, when velocity is negative. And that's happening from 2 to 7. Anything that's below the x-axis, we know that that particle is moving to the left. And finally, here our last question of the video is, we want to find the average acceleration of the particle on the interval from 1 to 8. So let's see, we want to find average acceleration. So how do we do that? Well, we're given velocity, okay? So in order to find average acceleration, that's going to be the derivative of velocity, or the secant line for that velocity function, which we're given in our graph. So we want to find v of 1 minus v of 8 over 1 minus 8. And of course, it doesn't really matter if you're going to go v of 8 minus v of 1, 8 minus 1. You can flip it either way and it's going to work out. So let's see, v of 1 I'm getting as 0, and v of 8 I'm getting as positive 3 up there. So I'm going to write 0 minus 3 over 1 minus 8 is negative 7. All right, so let's go ahead and look at our graph. So for v of 1, I'm getting positive 3. And then for v of 8, I'm getting also positive 3. All right, so if we're writing this down, I have 3 minus 3 over 1 minus 8, which is negative 7. But 3 minus 3 in my numerator, I'm getting 0, so this comes out to be 0. And let's go ahead and say, all right, so we know our average acceleration from 1 to 8 is 0. But let's also write down our units in this case because we are going by meters per second squared. So this review is going to kind of start us off into this lesson as we're starting to find net and total distance. And we're going to learn how to find those in different situations and really start to bring in a lot of our knowledge from derivatives. Of course, if you need any help on this video, if you don't understand anything or you're confused on a certain part, please reach out to me. I'm Mr. Hernandez, and this is Mr. Hernandez teaching.